All right, welcome back to the last portion of Notes 8-2. So number 9, it says in example B, one of the two possible solutions found to the equation was extraneous. Using a graphing calculator to solve the equation in example B, does the graph support the algebraic conclusion? Explain your reasoning. And I said yes, our graphs will intersect at 8. So let's go ahead and take a look at that, what that would look like. All right, so what we're going to do is we're going to use some kind of graphing mechanism to graph the equation in example B, where we graph the left-hand side of our equation, right, x as one function. So I'm going to graph y equals x as one function. And then we will graph the right-hand side, which is square root. Don't forget this is the same thing as a square root. So second square root, x plus 1, and then plus 5. And we're going to hit zoom 6 and look at this graph. So there's the graph of our original, and there's the graph, of our line, and there's the graph of our square root function. And then to trace this, we're going to go to the point where they intersect, which is at about 8.03, approximately 8. So the answer to this, right, it says yes, our graphs intersect at 8. So we already verified this one algebraically where we got 8. Let's look at the last one, number 10. Number 10 says, in item 6, you entered the left-hand side of your equation as one function and the right-hand side of the equation as another function, then found the point of intersection. Why is the x-coordinate the point of intersection to the solution to this equation? Okay, so we're going to go ahead and solve from example 6 or from item 6. We didn't solve this we didn't solve this one algebraically, so we're going to solve it algebraically. So our equation was 2 square root x plus 4 is equal to 6. If I were solving this, right, I would divide both sides by 2. To isolate my radical, I would get square root x plus 4 equals 3. I would then square both sides to undo my radical. I would get x plus 4 equals 9, and I would subtract 4 from both sides, and I would get x equals 5. Remember, the whole goal here when we're solving is we're solving for x, right? We're not solving for y. And so in our graph, we had that they crossed at, I'll show you that again. In the graph, these two functions crossed at 5, 6. And then algebraically, the solution is x equals 5. And so the answer here is we are solving for x. So the x coordinate is our solution. I do also want to verify that on number 8. So let's go back and take a look at number 8. We graphed number 8. Let's solve it algebraically as well. So we're on page 109, number 8. You notice something that I've been doing is whenever I write off to the side on a second sheet of paper, I put what number I'm working on, because as we're going through these notes, they're taking up more and more room. I do not have enough room in my Springboard notes, so you should be making extra pages for yourself. All right, we're going to do the same thing. We're going to solve this equation and see if we do indeed get 3. So to do that, I would divide both sides by 2 to isolate my radical. I get square root x plus 1 equals 2. Then I would square both sides. X plus 1 equals 4. Subtract 1 from each side. I get x equals 3. So my solution algebraically is 3, and I can verify that looking at my graph that these two do indeed cross at 3. All right, guys, this has been all of the notes for 8-2. I hope that you took good notes. I hope that you paused when you had questions. And I will see you tomorrow with any of your follow-up questions. Have a great day.